Join discord.gg/flatearth and enter a check-in room. Someone will come along and verify you to get involved in the conversation about our Earth.
Orsen.
New person in the server goes by the name of Orsen. Orsen doesn't have any role, so I'm going to do them the kindness of unmuting their microphone and then give them the ability to speak and introduce themselves to our lovely server. So, Orsen, in a couple of moments, which is about now, you've got control of your microphone. If you want to unmute yourself and introduce yourself, that'd be great. My name's Jedi. This is the 24/7 Flat Earth server. How are you?
Hi there, Jedi. Nice to meet you. Thank you for unmuting me. I believe that the Earth is a globe. That's generally the consensus with most people. I don't believe that there can be a big theme of a flat Earth. I don't think such a big conspiracy would be hard to cover up.
Have you checked the Earth, sir?
Well, I've seen satellite imagery. You can literally set up an antenna and receive satellite imagery if you wish.
Okay, Jedi started this. I'm just going to turn it over to him. Go ahead, Jedi.
No, but I spoke a lot earlier to the last gentleman, so I'm more than able and keen to let somebody else take it yourself if you want to, mate.
Oh, I'll be honest,
just
Jedi,
about
he's
to
my
give him
friend.
Yeah, I'm just about. Hello. That'd be great. Let me just give you voice verified, mate, so you at least have the ability to open and close your mic and then leave the live stream and come back with that same ability. And you can also join the live stream voice text, which is a text room just above this voice chat. We use that text room to run alongside this voice chat. We post relevant information in there and so on. So when I've given you that ability, it should just pop up, okay?
So satellite imagery, so basically that would be images on a screen, right, that somebody has handed to you with a story attached to them about them being representative of the place that you live in.
Yeah, in a way, but with satellites, you can get a measured distance of their distance. You can use triangulation. So if you know the position of 3 satellites, you can use the speed of light to calculate how far they are from you.
How do you do that on a curved surface, may I ask?
Yeah, so we do this with like GPS, which I don't know how you guys assume works on a flat Earth.
Oh. Sorry.
Yeah, that would be like my question. How would you?
You've only just jumped in. Are we going you brought up satellites, didn't you? And then you started talking about getting angles to them, and then GPS.
Yeah. So these are all.
Three things do you think?
I'll focus more on this, but they are generally the same idea. The way that satellites work, the way GPS works, is by taking the distance, taking the time in between the signal that has been sent.
Mm-hmm. I have to go real quick. I just have one question I want to throw out there. How do you possibly calculate the speed of light, which you say is 186,200 miles per second, to a satellite that you say is 300 to maybe 1,000 miles in the sky? How do you possibly calculate the time it takes that photon that's traveling 186,200 miles per second to get to a satellite in outer space? And there's so many things wrong with that outer space stuff. But how do you calculate that?
Yeah, sure. So that's a great question. I have a bit of experience working with electronics. To put it in like a simple idea, because the actual implementation is a lot more complex. But if I set up a little circuit and I say this circuit every in a certain amount of time, it will go over itself a billion times.
So what's this doing to establish that the world's a ball? Because that's what we're looking for.
Yeah, sure. So by knowing the distance between all 3 of these satellites, and if they are at the same altitude, and even if they're not at the same altitude, you can take this into account. it gives you can see as they travel around you, keyword around, as in it's a globe, until it meets the horizon of the globe, and then in which the signal will disappear.
How do you do this without any measured curvature?
Hold on. That's the bit that I think that we can focus on. Are you saying that you can't get a signal to a satellite in the vacuum of space because the curve of the Earth is in the way?
So with most satellites, you can't. There are complex ways to get around it, but essentially you can't get around the Earth with a satellite. Yeah.
So let's just check if that curve's actually there.
So the bit that I want to focus on is sending a signal to the satellite because the curve of the Earth is in the way. Physical obstruction, right?
Mm-hmm.
Okay. So this is probably one of the main reasons why we flat earthers are flat earthers. So that physical obstruction, maybe you understand it better if I say Greeks a long time ago figured out the Earth was flat because they couldn't see the bottoms of boats at sea. Have you ever heard that before?
Yeah, I'm familiar.
Yeah. So we can't see that at distance over water because the physical curve is in the way. Same with your satellites, the physical curve is in the way, right? What would happen to you if I was to take that physical curve of the Earth away from you? As in demonstrate to you that it wasn't physical, as in a hump of water, for example, if it was on the surface of the Earth, a hump of water, and actually an optical phenomena, depending on the technology that you use and the atmospheric conditions of the day. Horizon isn't physical, my friend. That's what I'm trying to tell you.
Yeah, but I think this is quite different from a boat disappearing over the horizon. This is
It's the same thing.
Is it?
It's the same thing. Your satellite.
What would happen? What would happen if I was say to you sunsets or sunrise? Why can't I see the bottom of the sun at sunset and sunrise, for example? What's blocking the bottom of the sun?
The curvature of the Earth?
Yeah. Yeah, exactly. So the curvature of the Earth. We are told that the curvature of the Earth is the reason why we can't do X, Y, Z. See the bottom of the sun, send a signal to a satellite, or see the bottoms of not see the bottoms of boats, or indeed, I don't know, countries. So, would you agree that if we can use a mathematical
sorry, go ahead.
formula, we can figure out where the geometric horizon should be for an observer standing on that curved surface? Yes.
Sorry, there, okay. Jedi. I think you're. I'm not trying to cut you off, argue with you. I'm just giving you a heads up. I think your reception's either really bad or your mic's cutting off.
No worries.
Satellite must have gone over the non-geometric horizon. So on that point, is the horizon geometric, sir?
Well, what do you mean, is the horizon geometric?
Is it a physical sphere edge?
Or is it optical?
It's physical.
Okay.
Right.
So then it must be at a certain geometric distance then, given the rate of curve of this globe, right?
That makes sense, yeah. There must be a distance to where it disappears.
Yeah, let's see if that distance holds up in reality. 1 second. Okay, the black swan has been posted in the live stream voice text. Do you see that?
Yeah. Well.
Okay, so geometric horizon distance on a globe with a radius of 3959 miles. 1 foot of observer height times the square root, times 1.225 miles. What the fuck? Yeah, so in that picture there, 1 foot off the surface, right? We should have a geometric horizon at 1.2 miles.
Mm-hmm.
Right.
Well, I think the issue I have with this is I don't know.
Yeah, I kind of jumbled my words. Yeah.
Well, sorry. It's more I don't know how accurate this information. I'm sure the math look like it must be done correctly. I'm just gonna assume that, but I don't know if
Okay.
you know,
Let
if the
me just
distances
start
between
again. So
these two are the same.
1.225. Yeah, let me just start again. So 1.225 miles times the square root of the observer height in feet. Geometric horizon formula for a globe with the radius of 3959 miles, as claimed.
Mhm.
Right. So in that picture, therefore, we have a 1 foot observer height. Camera is 1 foot off the surface. Right. So that should put that horizon distance at 1.2 miles if the horizon is the geometric sphere edge that you're talking about it being.
Yeah, but how do I actually know that the picture is taken at 1 foot? 1 foot. Am I when it comes to things like this,
We have the original video, so
Yeah.
we'll give that to you in live stream.
Oh yeah, that'd be great.
Yeah, it's a still from a video like Jedi just posted, and like Sonny just said, we have the original video, so you can look at that. It's 1 foot off the surface. If somebody wants to post it, memes Black Swan 6 is one you can use.
I'll post it.
So it's-
The original video is coming up right here. 1 sec.
Thanks, Sonny.
I have the
Besides, if you
I have the darkened image up there. It has the timestamp on it, actually. So that's the same image as the Black Swan. It's just darkened from the original video.
There's
The
something I should let you know, though, right? Because we're seeing the horizon in that picture past the furthest oil rig at 9.4 miles, right? So let's say somewhere around 10 miles is where the horizon is appearing, right? For observer height to cause that horizon distance on the globe, right, the observer height would have to be somewhere around 60 to 70 feet. You can clearly see from the original video that he's nowhere near 60 to 70 feet above sea level. So it's not even really a valid place to go. I mean, we could give you 5 feet of observer height. We could give you 10 feet. It's not going to make that horizon distance conform to the globe metrics.
When I'm just double checking everything, I'm gonna.
Yeah, you should do that.
I'm just gonna pull up some. Where is this? The Black Swan.
Yes.
Live stream.
California, Santa Barbara, I believe.
Rig.
Yeah.
Would-
So what are you checking right now? Moment.
So what I'm doing now is I'm just measuring that distance between those between those two objects.
Okay, between the two objects, between the two rigs?
Yeah, I'm just trying to. Does anyone have the coordinates of it?
Yeah, I mean, I could go find the link if you want.
If it's in the, I'll check the video if it's in there.
Yeah, it is. It's given in the original Black Swan video from Quantum Eraser.
Someone could post that.
So while you're checking all the background stuff, what we're demonstrating to you, and of course, yeah, this is just people that you're listening to on the internet, and you've just been provided with a photograph. The point to this is, if you had the ability, you could go and do this yourself. You could go and place a camera over any distance of water and look for the physical geometric horizon. You will demonstrate to yourself, depending on the atmospheric conditions of the day, and I don't know the technology that you use, the horizon will move, demonstrating that the horizon is not physical or it will move.
Well, I think it's important to ask, like, what would you say if there's evidence of the exact opposite situation?
How
Like,
could there
what
be?
What
Like
do
if
you
someone
mean by
did
the
have
exact
did have
Yeah,
a
but all the
picture
swans have all the swans have to be white, though. In other words, right, every horizon must be geometric in order for any horizon to be geometric. It would always be at that geometric distance because the surface of the sphere has the same rate of continuous surface curvature everywhere. Right, so that geometric horizon would have to be seen every time. If it's not seen one time, then you don't have a sphere with continuous surface curvature of the rate given.
What it's kind of poignant to point out at the moment is we're also making this observation over water. It's quite easy to understand the dynamics of water. It's level upon the surface,
Wait,
right? But when
wait a
presented,
Wait a second, that video, is he really 1 foot off the ground? Because I saw him walk up steps. Has he calculated the?
He's not
where-
going up
camera
the step
down yet.
for that
time
particular.
stamp.
Does he come down?
The timestamp is right there. If you just pay attention, at
And-
57 minutes after the hour, I posted it again. There's a original
Oh,
video.
yeah, I skipped
Shows
through.
him
He
setting it
hadn't.
up.
He
Oh,
He
will
hadn't
you
done
let
the
me
shot where.
shots.
So let me
This is why-
fucking finish. So
Yeah, go ahead, sorry.
you see him setting the camera up at the water line. Do you have any question about where he's setting the camera up and what he's looking at when he's looking directly down at the water at 1 foot and then just pans the camera up to see the rigs? Did you see that part?
Yeah. I'm just skimming. I'm just double checking with you guys.
Okay, good.
It's all good
No
to just
problem.
double check. But he does do some other observations too. He takes some other shots. He does take some from the stairs, but this particular one was done from 1 foot above sea level.
So the one where he goes up step, he's only 30 feet or so above, but we're talking about the 1 foot above, right at the water line.
And you're okay with the geometric horizon formula, right? The 1.225 times square root of observer height and feet.
I don't know the specific formula, but that's something I think I can trust because I think that's all public information. And
Yeah, it's derived from the.
Yeah.
You're right. It is. Yeah.
You'll find it in Earth curve calculators. Just type in Earth curve calculator and
Yeah.
you'll find it within the math. Because that's what we were told. Physical geometric horizon, right? Physical, as in beyond it, it's obstructing stuff. Like your friend goes for a walk over a hill and then he's on the other side. You can't see him because the hill's blocking the way. So when we're talking about a boat or a building, say a lighthouse or a shoreline or the sun at sunrise or sunset or sending signals to things, it's not the curve of the earth, physical or geometric obstruction. Something else. With observations, it's the limitation of your eyes or the optics or the atmospheric conditions of the day.
Yeah.
Not refraction.
Well, for it to be
Um,
refraction, yeah, never mind. Not going to go there yet because he hasn't gone there. Sorry, go ahead.
Thank you, Heretic. I mean,
to be real with you,
this is just an
I-
observation. I'm trying to also let you know that. Go on.
I'm just not too sure about this specific situation.
Fine.
I'm not
That's
absolutely sure
fine.
on the measurements.
That's fine. It's going to take
She
time
did
to
show-
look it
show-
over on. It's going to take some time to look it over on your own.
Yeah.
Because you are walking into a flat Earth server, but you already know that the formula is public knowledge. You're just trying to figure out, okay, what's this guy doing? Like Jedi said, you could actually do it yourself. You could actually go to this location as well. Any other location, you can use a boat instead if you have a ship tracker. But the overall point is, it's exponentially it's magnitudes off, orders of magnitude off. Not only that, guess what, it's still off even if you input 50 foot 60 foot into the formula. The horizon is still too far. When you say too far, it's still beyond what physical limit it would be if the earth were a globe with the radius that they've given.
Yeah.
So
But
you can be as
can I
tedious with
just?
this as you want, but it's it is what it is. That's why we're here.
I'm not super familiar with
What's your
this, and
adjustment?
I understand that it makes me sound a bit dismissive. And I suppose if one day I do come back here and have a talk to you guys, I'll have a proper disagreement with you guys instead. But if I could just go back to the point about satellites, we can measure
yeah.
the distance.
How do you know
We
that
can-
you would have? How do you know that you would have a disagreement? We're just giving you the facts. What is there to disagree? What do you think you would disagree with? That
Well,
that the Earth curve is not geometric. Like what's the disagreement here?
I'm just not familiar with this specific situation.
Well, as
And
far
I
as
would need more
satellites go,
time to go
as
through
far
it.
as satellites go, then
Right, yeah.
you know that they require elevation angles for the signals that you're talking about.
Elevation angle?
When you
No, never heard of that.
yeah, you know what an angle is, don't you?
Yep.
Yeah. So when you're looking at your satellites, do you say measure its angle above the horizon? That satellite's 20 degrees above the horizon.
Yeah, but I'm more talking about the measurements of distance that you can make with satellites.
We're talking about we're talking about just getting an angle to that satellite, or indeed an angle to anything that's up in the sky, like the sun or the moon or Polaris or any star.
Well,
Same thing.
the thing is, though, is this was your point about satellites, though, because you invoked the horizon when you were making that point. So we went to, okay, let's see if that horizon is actually curvature, right?
Yeah. But if I could just have like this one question answered, right? This is all I really have prepared because it's the one thing I know a little bit about. Is that we can measure distance between our location and satellites, and we can measure, and if we need to, we could measure, and it would be consistent with the reported location and the distance of that satellite. And
using elevation
Yeah.
angles.
Okay.
Yeah.
Okay.
Yes, but is the horizon that your argument invoked consistent with the globe Earth?
Well, even with satellites, the horizon is just a horizontal surface. Like I said, it requires elevation angle measurements. So either you want to talk about the horizon or you want to talk about elevation angle measurements as, it's relevant to the satellites and the distances that you're talking about.
Yeah, but what I'm trying to talk about here is that by knowing the distance you are from a satellite, you can create an image of where that satellite is. And it gives, and you don't need to rely on
The measurement to get the distance, you mean? Because that's what we're talking about. We're talking about the measurement that gives you the distance. I think what you're missing is what an elevation angle is. You know what? I posted the video in the chat. It's like literally like 15 seconds, 20 seconds, because I don't think that, like, we're talking about the same thing, but you think we're not. So I think that if we watch this video, it would elucidate what we're talking about so that you know that we are on the same page. Do you mind?
I've watched the first 15 minutes. And the other thing is, I don't know what the bottom of that platform actually looks like.
No, you didn't. We're talking about satellites now. So you either want to talk about the horizon and the Earth, or you want to talk about satellite distances.
Okay.
It's clear that that's the subject that you came prepared to talk about. So I'm asking
what I'm trying to argue here is,
look, what you're arguing. I'm giving you a rebuttal, and you don't understand. So there's a breakdown in communication because I'm responding sequitur to what you're saying, and you don't get it. So in order for us to continue communicating where we both understand, I'm just asking you to watch this 15-second video.
I have.
Yeah.
You haven't watched it yet because I haven't posted it yet, just so you know.
Do you mean the first 15 seconds of the video?
No, not the video.
Okay.
He's going to post it. It'll be up shortly.
Yeah. But do you guys actually believe that satellites are real?
Why would you have to believe?
Right,
Why would you have to hold on? Why would you have to believe? Can I answer? Why would you have to believe something if it was a fact?
Hold on, but we're talking about elevation angle measurements of satellites. So, what is there to believe? Like I think that we all observe and see the world for what it is. It's just other people have added beliefs about it. So since that's the case, I'm just trying to share information that I have about the satellites and about the distances that they get. And so I need you to see the fundamental properties of this so that you understand, hey, there's a problem here.
Yeah, I'm waiting for that video so I can. But while we wait, if you can measure the exact distance of a satellite from you, right?
Yeah. Yeah.
And if that distance,
Then the Earth has to be a ball.
pardon me?
Then the Earth has to be a ball.
No. Well, then you can measure. If you can measure the distance between you and a satellite, and that satellite is going around you in a shape of a circle, doesn't that sort of
How did you
prove that
measure
they're...
the circle? How'd you measure
Hold
the
on.
circle?
Hold on. I'm letting him talk so I can respond.
Oh yeah. How do you measure if it's a circle? Well, you can have multiple measuring multiple measuring locations. You can have, you know, if it's one half is consistent and the other half is consistent.
I suggest you watch the video first before we talk any further about the horizon. So this video, just preface, I think it's necessary. It's from Globers, a Glober perspective, telling you how to find the distance to the geometric horizon. This is your claim of a globe Earth. So when you get the chance, go ahead and listen. Is that posted yet?
Yeah, I'm watching it now. If I could have a second.
Yeah, it's there. Sorry, it's not 15. It's 37 seconds. Hope you don't mind.
Oh, it's not in the live
I'm
stream.
just gonna definitely mute myself for a second so I can watch it.
I'll post it again for everyone in the live stream voice text called How Does the Horizon Work?
No, Sonny, we're not having that conversation.
Oh, we're not. Okay.
There's also another citation I like from NASA themselves when they talk about the use of satellites practically with conventional heights using a flat, non-rotating Earth as well. But I don't know if Miguel, he would have it if he was in here.
And Hoymar's back in town. Mr. Sex Robot himself. Welcome back, Hoymar.
It's been like a minute.
Well, what is the point that is trying to be made with this video?
That they use elevation angles to read the signals to talk about distances, how far whatever is from X position.
Mm-hmm.
So now, can you Google what an elevation angle is?
I've looked it up.
So what is it?
It's the distance between something at the direct distance between something at the ground and something sort of like the what's the English word? Pythagoras?
Two lines meeting at a vertex, a horizontal line, and one in the vertical axis. That gives you an elevation angle. And you know the point that I'm making, because for the math, they're not using a sphere or globe, at least not in this example. You can look at the entire video. But in order for any of the practical stuff to work, we're going to assume the earth is flat, even though he says it isn't. That's the math he's doing.
Oh, no. If we want to calculate the position of satellite, we don't need to use like
Angles?
yeah, no,
Because you need a measurement before the calculation. That's the point. You don't just do calculations willy-nilly.
Yeah, no, but if we can use the speed of light and use that speed of light to measure the distance of an object.
Can I simplify this down a little bit, please, Elijah? Would you mind?
Hello?
Yeah, it went a little bit dead there. Elijah, you still with us?
I said he got a call in the VC text
He's
chat.
got a call. Okay. Let me try and break this down really simply. Would you agree that we can get elevation angles up to things in the sky? Satellites, the sun, moon, and stars, for example.
I don't know.
Would you agree? Have you ever heard of celestial navigation?
No.
No. Have you ever heard of something called navigating with the stars?
Oh, yes.
Yeah. So using the stars to navigate across the Earth. You've heard of that, yeah?
Just real quick. If there is English is my second language, so if there's a word that's very crucial for me to know, just tell me and then I can Google it.
Cool. Awesome. Do you know what a triangle is?
Yeah.
Awesome stuff. 3 straight lines meeting at 3 vertices where you can read 3 interior angles reaching 180 degrees, yes?
Yeah, like the I don't know the English word, Pythagoras. It's
Yeah, Pythagoras.
Yeah, that.
Yeah. All of that triangle stuff. Would you agree that you can't measure an angle if one of those lines is straight? Sorry, if one of those lines is not straight and curved, for example, you wouldn't be able to measure an angle, would you?
Well, I don't feel like this argument matters when you can measure it with the speed of light.
But I think what we're trying to let you understand is just something very simple like measuring an angle to a star to navigate across the Earth. That's what we're trying to get to. You mentioned satellites and measuring to them. We can measure angles to things in the sky, can't we? This is the very simple bit I'm trying to get you to understand. So we're on the same page. We can measure angles to things in the sky, sun, moon, and stars, for example, and just satellites.
I suppose.
Yeah, awesome. So you understand that you can't measure an angle if one of those lines is curved, right? If you've got a triangle, one of the lines.
Yeah, I understand the question. You can't do the equation. You can't measure the base of a triangle if it is. You can't do the base of the triangle.
No. So when we're navigating using the stars, we're drawing a triangle between you, the observer, that star that you're looking at, its ground position on the floor, which is a straight line down, and from that position there, a straight line to you. A triangle, right?
Mm-hmm.
Okay. So, being as we can measure the angle up to that star at a known time of year, because it comes round every year over a certain spot, we can navigate across the Earth, yes?
I feel like this isn't really
Yes.
addressing what I've said with the.
Yes, I know. So follow me. You've come to our server. I'm trying to take you down this path because you seem like an intelligent man, talking about satellites and so on. That's fine. I could have taken satellites away from you at pointing out that that's not a vacuum up there in the sky that that's said to be travelling around it. We haven't gone down that path. I'm just talking about triangles and measuring two things in the sky, something that's really simple, and I hope you understand. Because if you understand this, that we use triangulation and triangles to measure angles to stars to navigate across the Earth. If you understand that you can't measure an angle if one of those lines is curved, but the Earth is said to be curved, then we wouldn't be using celestial navigation angle measuring devices upon the Earth. So the Earth has to be flat for us to navigate across it using celestial navigation, navigating with the stars. That needs the Earth to be flat, that does. So we can talk about satellites. You're going to measure angles up to them 10, 15, 45 degrees above the horizon. But as soon as you say angle, you're going to need the Earth to be flat.
Yeah, but that still doesn't matter when you can go out and buy
and use a sextant and navigate across the Earth, requiring the Earth to be flat.
No,
Yeah,
no, you
we
can
can
go
all
out
do
and
that.
buy the required equipment to measure measure the distance up to that satellite with the speed of light.
Awesome. Where's the satellite?
In space.
What space?
Say again?
What is space?
It's nothingness.
So a vacuum, yes?
Yes.
Awesome. Is the Earth an open system? Can things leave the Earth like satellites or rockets to the moon? Is the Earth an open system?
It can with enough force. But if it does not have enough force, it can.
Yeah. Is the Earth an open or a closed system? Can matter and energy transfer from one to the other?
With enough force to leave the gravitational well, yes.
Oh, okay. I understand where this is going. Hear me out, my friend. Would you agree that you're breathing gas pressure right now?
Yes.
Oxygen, nitrogen, those types of things. Would you agree that that gas is under pressure? Yes?
Yes.
Yes. How do you have gas pressure without a container? If the Earth is an open system, not a container, how do you have gas pressure? Because gas pressure is the force that the gas exerts upon the walls of its container, like a tyre or a football, for example.
Through gravity.
Okay. Do you have a scientific experiment that proves gravity, please?
Me specifically, no.
Is there a scientific experiment that proves gravity?
I'm sure there is, but I do not have it on hand. So.
You sure there is? So you were talking about, you said gravity well. Would you be talking about Einstein's relativity and the bending and warping of space-time? Is that what you're talking about?
No, I'm talking from a much more top level idea of it.
More than Einstein and his mathematical equations.
No. The opposite of what you're trying. More surface level.
Okay. Would there be a scientific? All right. Let me point this out to you instead of just asking you questions. There isn't a scientific experiment that proves gravity, my friend. whether that be mass attracting mass or the bending and warping of space-time or any idea. There's no scientific experiment that proves gravity. But I'm just talking about gas. Which way or direction is gravity, my friend? If I was to drop something like a rock, which way does it go?
Inwards to the center
Yeah.
of the
So
Earth.
downwards. Yeah, so down.
Relative to you,
Zero.
downwards, yeah.
Awesome. When I uncontain gas, say pop a balloon or a tire or a football, which way does the gas go?
Depends on the gas.
Which way does it go? Does gas disperse freely?
Very.
Hold on. Does gas disperse freely and randomly in all directions, as described in gas law?
Depends on the if it's just air, yes. But if it's a different gas, it can.
Move. Yeah. So, for example, let's just talk about any gas. Doesn't matter which one. I've got a vacuum chamber. You understand what a vacuum chamber is, don't you?
Yeah.
Awesome. And halfway up the vacuum chamber, choose a size, don't care. Halfway up the vacuum chamber, I've got a nozzle that I can impart gas into that vacuum chamber. I don't care if it's helium. I don't care if it's sulfur hexafluoride or whichever gas you're talking about. I'm going to open this gas and let it go into the vacuum. Which way does that gas go in the vacuum?
What do you? So if you have it would disperse throughout the vacuum. Yes.
Yeah. So it would disperse freely and randomly in all directions and would press on the limitation of its environment. Yes.
Could you rephrase the last part?
Gas disperses freely and randomly in all directions and presses on the limitation of its environment. The vacuum chamber, the container, for example.
Yeah, I'm just trying to understand the last part there of that sentence.
That's fine. The gas is pressing on things, right? The walls of the container. And then when you've put that gas into that chamber, the consequence of you putting that gas in there is the gas is under pressure, right?
Yeah, but if are we assuming the vacuum is no more now?
Well, it's got gas in it, hasn't it?
Yeah, but are we assuming that the outside of the vacuum chamber is Earth's atmosphere?
Yeah, we're doing this on the Earth because it's the only place that we can do it. But ultimately, the gas inside the chamber goes in all directions, doesn't it?
Yes.
So it doesn't go down like gravity suggests when we drop rocks. It goes freely and randomly in all directions. Even if I was to say, I'll give you gravity, even though you don't have an experiment, I'll give you it. It observably doesn't affect gas. Gas moves in all directions and is only limited by the container that it is in. If you remove the container, the gas will keep expanding, right? So if the Earth is declared to be an open system, we wouldn't have gas pressure because there's nothing to press upon. And if out there's a vacuum, the gas would disperse into space. Now, that's not me saying that. That's second law of thermodynamics. That's entropy. High pressure disperses into lower pressure environments. Always.
Yes, but it's the gravity.
What gravity? Hold on.
Gravity of the
Earth. Hold on. One, you don't have a scientific experiment that proves gravity. You just believe there's one out there. But two, even if I was to give it to you, it's not affecting gas. Do you understand that even if I give you gravity, it's not keeping the gas here? You might think that it is, but it can't violate a law of nature, because if it did, that wouldn't be a law of nature now, would it?
So, in this hypothetical that you say,
not hypothetical.
Okay. Would you? Are you saying that this would not work even with gravity?
Even with gravity.
Even
if
with gravity.
you can't. Yeah. Which way does gas go? In all directions, Jedi.
In all directions. Uh-huh.
Yeah. So you claim gravity is inwards towards your ball. You drop a rock. The rock goes down. That's gravity. But gas going in all directions, that's not gravity because it's going in all directions. Here's a question for you. Where's the gas produced on the Earth?
Well,
Where's it
I
made?
think
Where's
Where's
the gas?
before I address that question, I want to address your last point. The gas is also dispersing along with the other gases around it.
Yeah.
It doesn't exist by itself. So I'm just.
You understand that gas disperses in all directions and feels the limitation of its space, especially if that space is of a lower pressure, like a vacuum. Yes?
But the principle you are applying here is when the material is with other materials of the same properties.
Or gas?
Yes.
Yeah, gas disperses in all directions and doesn't go down like rocks does when you assert gravity is a force pulling things to the centre of a ball without a scientific experiment and without gas doing the same thing.
Yeah, but there's other gas there.
Yeah, and what's contained in that gas? What's the gas at the very top pressing against if it's not dispersing into the vacuum that, according to laws of nature, it is freely able to do so because the Earth is declared to be an open system?
It's pressing against gravity.
Gas.
Well, not pressing against, but being pulled in a way.
In a way. So what you're saying, do you understand what the inverse square law is? The further away from the centre of mass gravity decreases. Do you understand that?
Yes.
Awesome. Where's the gas produced? Where's the gas made?
What do you mean? Where's the gas produced? On Earth?
Where on
the new
on
gas,
the
at
Earth
least.
is? Yeah, where's that made?
Gas can be produced in many ways.
Biological and chemical cycles that take place on the flora and fauna of the Earth, right? Down here at ground level.
Yep.
Yeah, inside the mass. Yeah? And then it goes away from the mass, disperses in all directions, and feels the limitation of its space. But you say that eventually, even though gravity decreases with distance, that gas that was escaping the Earth straight away is going to turn around and come back. Can you show me that, please? Because gas moves freely and randomly in all directions and would disperse into a vacuum if there was nothing physically containing it and making it stop, something to press against. So this is what I mean about not having observable phenomena. If we're talking about science, you need to have something happening. Gas isn't happening in the way that you want it to happen. Gas is moving away from the Earth. You say it stops. Why? Gravity's weaker up there.
No, but there are other forces. It isn't just gravity. It's also the pressure from the air below.
Below. And what's the pressure on the air above? And what's the pressure on the very, very top? What's that pressing against? Why is that not dispersing into the vacuum that it's adjacent to? That it should do according to the second law of thermodynamics and entropy. Because high pressure disperses into lower pressure environments. And that's a big vacuum, the vacuum of space. You know what Jupiter is, right? A giant ball of gas, yeah?
Yes.
In the vacuum. Right. Imagine that giant ball of gas with a football around it, like a rubber ball. Now you can understand how the gas was kept inside the rubber ball and not dispersing into the vacuum of space. And if I was to magically click my fingers and make the rubber ball disappear from around the gas, you would understand the gas would disperse into the space, right?
Sorry, I'm still thinking about the last question.
What was the last question, mate? You got an answer for the last question?
I think I do, but I'm trying to phrase it. The gases at the top of the atmosphere tend to be the lighter gases.
Yeah, which are free to disperse into the environment around them that if it was of a lower pressure, which the vacuum of space is declared to be. So there's nothing able to keep them here, and there will be nothing to keep all the other gases here because gases disperse in all directions outwards.
But if the gases surrounding it of lighter are lighter gases,
And
then
they
it
would
wouldn't
disperse.
be.
What's physically what's stopping them from being here? Gas does not contain gas.
Yes, but it's the gravity of the Earth.
No. One, there isn't a scientific experiment, as I've tried to help you understand. You haven't been able to provide me with one. You just believe that there's one. Two, I'm trying to point out within the first step of the scientific method, we need to see something happening. Because our question in science is, what caused that to happen? Cause and effect. We don't have the effect when we even try to backwards engineer and attribute gravity to gas. Gravity is not affecting gas. If I give you that is the cause of anything, which I don't have to, because you haven't scientifically proven it. And I don't mean you, I mean they. They haven't scientifically proven it. It's not you. So when you say the vacuum of space, or rockets to the moon, or remote control cars on Mars, they are declaring that this all happens in a violation of laws of nature. You cannot have the gas pressure which we enjoy without physical containment. If you don't have physical containment, you won't have gas pressure. And guess what will happen to the gas? It will go away and disperse into the lower pressure environment.
It's I understand what you were saying.
Good.
I mainly came in here to talk about satellites, not I don't want to seem like I am dodging here. So I wasn't super prepared to be thinking about this issue specifically.
That's quite all
because
right. It's not
I'm
about
not
being prepared. It's about the
I'm
truth,
not
right? Because
super educated on it. Well, I don't have all the resources that you would have because I'm sure you're much more prepared.
My resources are your resources, brother. It's not like some kind of cafeteria fight or some kind of debate. This is real life we're talking about. You see what I'm saying?
Yeah, but I admit that I'm undereducated on this issue, but it's the issue of measuring.
It's not about your level of education. People with all walks of life come in here. People who have certain education in other areas. These areas we have astrophysicists, students who come in here. We've had physicists come in here, engineers come in here. There's a lot of people come here. It's not really about your educational background, right? Because we're all talking about really one thing. It's no big deal if you know something or if you don't know something. you know, as we were trying to talk about before with the satellites, it's like, well, in order for the satellites to have an orbit around the circumference of the Earth, they would have to have measured it that way, and we know that the ground doesn't measure that way. From the first
Yeah,
point that we spoke
but
about.
that's
So, you
that's
do know
where I
that you do know
disagree. They
you
they don't have to measure it with a
no, but what I'm saying is you can't
Pythagoras.
say that you have to calculate something and not have a measurement first, my friend. Because then
Well, yeah, and you have a measurement of
we're
the
just
speed
talking
of
about,
you have a measurement of the speed of light.
yeah, but that's completely non sequitur to the measurement of the Earth. The measurement of the Earth is necessary for orbital mechanics, not the speed of light. You
Yeah,
understand
but
that?
you if with the using
No,
light
hold
as a
on.
medium
Do
as
you
a
understand that it's non sequitur to the shape of the Earth and the necessity for satellites to orbit it? Do you understand that? Because if you don't, like, we can look at the definition for non sequitur, and then I can show you that, if there would be a premise, the premise being that there are orbital mechanics and the satellites and everything else that orbits the Earth, then the first premise must be true, that
well,
the Earth is a sphere
no,
with a radius of
I just
3,959 miles, sir.
I just googled the definition of non sequitur, but this is if you measure simply, I don't feel like I'm getting this issue addressed. It's the issue of if we know the speed of light and we know
Yeah, but you didn't address that that's a non sequitur. That's why you're trying to just repeat what you said last time. I heard what you said. My rebuttal is that's actually a non sequitur. Because if you're going to use the speed of life as the speed of light as a proof, then that's just begging the question. Yet another logical fallacy that I can justify calling you out on, because the formulation of your argument is exactly that, and we can look up the definition of begging the question as well. Like and I'm not trying to say that to intimidate you or stop you from making a point. What I'm saying is I actually justifiably rebutted the point, and so for you to respond with a repetition of it is kind of absurd.
maybe you are responding to this, and maybe perhaps, but I
Man, you
do I
man, you cannot
Don't
you cannot
interrupt him,
get
Sasha. Wait a minute.
sorry.
Let him think it through. Go ahead, sir.
what do you mean by non sequitur? So I am changing the. Am I making a point? I don't feel like I'm making a point completely different from what.
No, it's that you're begging the question by talking about the speed of light, proving that satellites are going from one distance to another. Well, first and foremost, you would have to have a sphere for all of that to be prerequisite to that. Well, the prerequisite being the globe. Sorry, that would have to be first proven, because if this is proof, then that makes it a begging the question fallacy. But really, what satellites are doing in the speed of light is completely non sequitur to the premise of orbits and the premise of the Earth. There's no relation there.
Well, there is.
No,
So
no, 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 there really isn't, because the speed of light doesn't necessitate the globe Earth in
yeah, but
itself.
yes, it
And
does. But if you can,
No,
no, I'm sorry, neither do orbits. Those two things are independent of the speed of light. That's what makes your argument non sequitur and at best begging the question, if it is your proof. second. I was asking someone to ask you to read what I've posted because we were talking about elevation angles at one point, which is really what this boils down to.
Sorry, I've come down with the COVID.
Did you say you came down with the no globe? Oh,
The COVID.
say it again and we'll ban you.
Is that another thing here? Gonna get into that.
It's off limits.
Yeah, I don't.
If you have, can I ask you, if you have any speed, let's say any speed or whatever, can you, with that speed, make realize what the shape of object is?
Well, you can get the position of the object continuously, then you'll be able to map it as an orbit.
What about the surface itself?
Of the surface itself?
Yeah.
Hypothetically, you could.
No, hypothetically.
Well, no one has, but the way you would do that is by using many positions. So it's only as accurate. So if you imagine people.
No, I'm asking about measuring the surface.
Yeah. So if you put people.
Do you know what is sphere?
Fear?
Sphere.
Fear with an S or with an F?
Sphere, ball.
Ball, yeah. Sphere, yeah.
Yeah. Do you know what is drop over distance?
I think there's another word for it.
If you put on the ball one point A and point B, does between that 2 points is it drop or is it curving or it's straight?
Curving.
Okay. We are looking for that in reality, for that drop over distance with given size of the Earth.
Yes, but I don't have permission to share my screen or
do you know the size? Do you know the size of the Earth? Do you know the size of the Earth?
Are you asking if I know the claim size of the Earth, or if I know the? I not by heart, but I can look it up easy.
Okay. And can you look it up and see how much you can see on the globe with your height?
Oh, are you going to do the Pythagor?
Yeah, 1.225 miles times square root of observer height in feet again.
Yeah, I want to avoid this.
You know, you was just about to invoke Pythagoras when you were talking about the speed of light, right?
No. This is different.
I know this is different, but what I'm saying is you tried to invoke Pythagoras earlier. I didn't hear you when I cut you off. I'm sorry.
No. I was trying to talk to.
No. Do you deny that you tried to invoke Pythagoras earlier?
In relation to the speed?
No. Just period. Did you bring it up at any point?
Yes.
You did. Okay. So I understand that this is a different subject. I'm not 5 years old.
I'm pretty confident you did say.
Right, something. But you were going to say no. This is different, but that's a waste of speech. I'm just saying it's interesting because you were trying to talk about Pythagoras earlier. So there's no reason for you to stop Heretic from talking about Pythagoras now.
Oh, you can talk, but I'm.
You can go ahead.
This is not an
Heretic,
issue I'm
sorry.
confident talking about.
No, it's all good. We kind of already ran through it. Like we did the geometric horizon, and we did that whole thing. So
And how? What did you get? Did you get something from that?
I think I know the gist of of that whole argument. Like I said, I don't think I am fully prepared to talk about that. I mainly came here to talk about the distance measured due to satellites.
And that will do what? If we realize the distance to the satellites, what that will do?
Well, if you continuously measure, you would the distance would change, and if you map that distance out on a plot, you would see it as a curve, as something being revolved around.
Okay. Can I check that in reality now?
Yes.
And I check it, and there is no drop over distance, man.
What do you mean?
There is no curvature in reality. I check it.
Can you explain further?
Explain. There is a size of the Earth. Sphere. If sphere is 10 centimeters, then you have the size. Then you know how much drop over distance. But this size is 24,000 miles. And then Heretic told you that it's 1.22 miles. That is the size of this Earth. Do you agree with that?
Sure.
Yeah. And when we go to check the size, there is no such thing called curvature in reality.
But I the reason I keep bringing up the satellite, I never feel like I'm getting addressed.
But I'm telling you now, I could believe you in that. Okay, great. This is showing this. Okay, good. Now, can we check the surface and see if is that all true? Because if it's curving regarding the satellites, it must curve also in reality, like physically, or not?
it's a simple enough thing to do. Should be curving at a certain rate. Should be a certain geometric horizon distance based on that curve. We simply go out, check it out, see if it matches.
Yeah. Do you think we could do a simple, drop over distance test at the shoreline? I've done numerous over and over. I've done actually over 100 of these at the shoreline myself. And there's no curvature anywhere. And actually, I've navigated on ship before. We use right triangles. You cannot have the surface you're traveling on be a curved surface and use a right triangle and find your correct location, period.
Wait, my mic's open? What the hell?
No, this is Sunny. I interjected. Yeah. So everyone uses elevation angles in reality for all practical purposes on or near the surface of Earth, or even below the surface of the ocean, including submarines, torpedoes. No one uses curved Earth math. It's not necessary because the Earth is not curving.
Sasha,
Yeah.
So if I came to you with, if I sat you down, I showed you the hardware and the software to prove that this wasn't doctored.
Man, listen this.
And
You will show me the software. You know, the software is coming from where?
I could show you the source code even.
Where is that? Where is that data coming from? From the satellites, you are saying?
It's coming from the satellite, which
Yeah.
can.
How,
If you're worried, if you are.
how you and me can verify that?
So what you can do is.
I'm asking this. This is very important question. How you and me can verify that
Yeah,
is coming from the satellite, from the space? How we can verify that?
So what you can do to verify with this specifically, if you imagine a satellite dish.
I don't want to imagine. I want to verify that it's true, that it's coming from the space, and that it's coming
Well,
from the satellite.
this is provable. This is.
Did you fucking say imagine and now you're saying it's provable? What the fuck, buddy?
I'm saying imagine
No,
to
that's
create
fine.
an image
That's
and
fine. No,
create
guys,
an image in his
that's
head.
fine. Here's the thing. That's why I said it's begging the question. Now, that's not significant. That's actually the justified rebuttal to what you're saying. Okay? Unless you're like, what is your argument? I mean, because if you're saying we can use the speed of light to look at distances, I don't know what that means.
What that means?
What is the conclusion?
Well, the conclusion is, let's say it takes these aren't the real numbers, but I'm using simple numbers for ease of understanding here. But let's say I get light here and I measure the light, and it takes 1 second to get back, and I do it 5 minutes later, and it takes 1.5 seconds to get back.
Mm-hmm.
I can measure the distance and the change in distance that has been created. And if you have many measurements of the change in distance,
elevation
you can create a picture of what is happening, of what is the movement of that object.
Well, why to create the picture when you have the picture?
Shut up. And what's the conclusion?
The conclusion that it is revolving.
Okay, that's begging the question, sir.
What do you mean?
Yeah, you need a globe for that.
You assume the globe in the first place, and they are putting the data on that globe. That's
well, if an object is revolving, it cannot. Are you saying that it is revolving around a flat plane?
The measurements that you're talking about, they're elevation angle measurements. That's why I showed you the video I showed you in the beginning. You can't say no. That's exactly what it is. He talks about the time it takes and everything that you just said. So you can't say no, because that's not a justified rebuttal to what I'm saying. That's kind of unfair, especially when you have less knowledge about this subject. Like I'm telling you what it is, and I gave you a hostile witness, a globe earther.
Yeah, but when you
no. This is a justified response to what you've been saying. There is no yeah, but.
You are using the assumption that this is using angles to measure the distance.
He's talking about satellites, and he's saying exactly what you're saying.
It does not use angles in this measurement.
So you know what? Do you have a citation to drop in the chat for us? That would help. And make sure it's a citation that supports your argument right now about the revolving and there not being elevation angle measurements or anything like that. Support that. Is that fine? Is that reasonable?
I will find you a.
All right, so we got time. Don't rush.
I thought this was. Okay.
Don't rush. We got time. No need to throw up all over the live stream. You know what I'm saying? Just
Would you guys accept a citation from
listen.
NASA?
Listen. Yes, that supports your argument, and then I want the support to go with it.
I have the source here.
Yeah, you're gonna have to cite it within the source. Cite the part that supports your argument, and then then we have to find the support for that. Sorry, I might have lost a little service there, but in case I was unclear, go ahead and find the part that supports what you're saying.
Yeah.
And then we'll look at the information that supports the claim.
So I've posted the information. So this is the explanation of how the satellites use light to measure distance.
You see how it says right here, to make such a calculation, the receiver, someone on Earth, must be able to tell precisely when the signal was transmitted and when it was received.
Yes.
Okay, so that would have to do with the elevation angles I was talking about. You said no, it didn't. And the guy explains it perfectly well in the video. Not in the short part of the video that I sent you, but in the video in full. And he's a Glober, so why'd you deny what I said was true? Well, why'd you deny that it had something to do with your argument?
I think by angles
I'm sorry,
of
when it
elevation.
explicitly does.
Do you mean using the distance plus the angle to calculate the distance?
They're doing something on Earth, right? That's where the receiver is.
Yes.
Okay. So
Could you? Okay, I'm sorry.
Right.
Maybe some
because
miscommunication here. Could you clarify?
It's prerequisite to the calculation, specifically right here, to make such a calculation, the receiver, the person on Earth.
Yes.
And this is vague. If we could get more, that'd be great. Because
I didn't know.
This isn't supporting your argument against me, is what I'm saying. You're supposed to get a citation that explicitly talks about the speed of light without the use of elevation angles.
Can you clarify what you mean by elevation angle?
I mean, you got the video right there.
But can you explain to me?
Well, the satellite is at a position somewhere, right,
Uh-huh.
over the Earth, and you have that vertical angle, and you have the horizontal plane that you're getting that vertical angle off of, like the video shows, and like the guy explains.
Can I read the definition, Elijah? Elevation angle is defined as an angle between the horizontal plane and oblique line from the observer eye to some object above his eyes.
But you aren't using the horizontal
Or
plane
in
in the
this case,
calculation.
the equipment on the ground. So the calculation again comes after. So you said that it had nothing to do, but actually it's dependent on the measurement. That's the
But
problem.
you are saying using the horizontal plane. So do you mean you use the angle plus the angle plus horizontal plane to find the
Well, horizontal is
distance?
just like the zero angle that you begin with,
Yeah, a
where
flat
you are.
surface.
Yeah.
Exactly.
Can you make angle with the curved
But are you standing on a flat? Are you standing on a flat surface?
Yes.
Maybe not in your exact definition.
No. Are you
I don't feel
standing
like
on a?
I can concede
No, I'm
that in this
sorry. Let's
situation.
rewind. Are you standing on a flat surface?
To my
Yes.
observable
No. It's a
ability, I
simple
am
question.
on. To my observable ability, I am on a
Yes
flat
or no? It's a
surface.
simple question. And in the case of having an angle where there's a right angle and a line directly from you to the ground position,
But it's not using a right angle.
not in this instance.
No.
So
Can I have the full video of that guy
I
you were
mean,
talking about?
how do you get an angle without two lines? That's the point.
By knowing the speed of light.
What?
What do you mean? No, you
Because
take
if
the
you know the speed
measurement.
of light and
Time
you
out.
know
Time
how
out.
long
Not
it
no. Not no. The problem is the measurement came first. We're not. You can't. I mean, that's absurd.
But if you know how long it takes the light to get there and back, and you know the
No,
speed of
yeah,
light
but
is
that's the
constant,
calculation that happens after you have the measurement. That's the problem. We keep going in circles. I don't know why this is happening. Do you deny that the calculation comes after the measurement? Do you deny that the calculation comes after the measurement?
the calculation comes after the measurement.
Sir, do you deny that the calculation comes after the measurement?
I have answered.
No, you didn't. Yes or no? Do you deny that the calculation
I
comes after the measurement?
did you hear me answer?
Was it a yes or a no?
I have answered. It feels quite demeaning
Is it a yes or a no?
to be pressured like this to answer in a specific
Is
way.
it a
I have
yes or a no?
answered, and I have answered.
All right, well, I'm going to mute you and I'm going to go back to the live stream then. If you don't want to say it, I'll just go back to the live stream. How about that?
I said the calculation comes after.
Okay.
The calculation comes after?
Yes, I said that, but then
Okay, so then what's your rebuttal to what I'm saying?
You're saying that you are using right angle triangles and
No, that's not what I
or
said.
an angle
No, that's
or
not
an
what I said.
angle.
That's not what I said.
For me, could you clarify one more time?
Well, just like the guy in the video, you have a flat baseline and then you have the angle to the satellite. What's the issue? So we're talking about the surface that this angle is being measured on. And it's either a horizontal surface or it's not. Now we already know that Looking at the math and diagrams here, that's exactly what it is. So what's your justification to say no, it ain't? That has nothing to do with them using the speed of light. No, he's talking about the speed of light. You can see the equations right there, but he's not using a curved surface. So I guess what I'm trying to say is, what's your point, bro?
Could you send me that full video of that guy explaining?
Of course I will.
Thank you.
And if you know the history, when ships was crossing the Atlantic or oceans, Columbus or Magellan, or they didn't thought about speed of light. You must know that they had sextant, and they measured the angle of the elevation, and then they got distance and they traveled. But still, if that's not true, we can check it always in reality. Orson, if you see the 10 miles of flat surface, how we will call that flat surface?
Pardon me?
If you see 10 miles of distance, flat surface, how you will call that?
Isn't the answer kind of in the question?
Well, I'm trying to
If I
understand.
see,
If
I see 10,
you would call it a flat surface.
okay, and I see 10 miles, why I cannot call that flat surface? Because there is a sphere.
Is this argument about the wording?
Yeah, because I'm not speaking now. The math is it's that horizon should be 1.22 miles, but I see 10 miles, How is that possible? And how I will call that if I and you answered, I will call that flat surface. Because of that, we calling flat surface, because it's flat in reality. Only because of that, not because we want to be flat surface.
You silenced him.
You
No,
believe in that.
I'm watching the video about the
You want to realize something about satellites. That's all right, but you cannot verify that, man. You don't know if is that real. You personally cannot verify that. Do you understand that?
Yes, you can.
No, you cannot.
Why can't you? The equipment is not impossible to get.
Okay. Question: Is it easier? What is easier to find out where is the satellite, distance to the satellite, speed of the sunlight, and to realize where is the curvature, or measuring surface itself? What is easier?
Well, with the satellite, you get a receiver, you plug it into your computer, and you walk out with an antenna. I would say that is easier.
Oh, okay. What about you get antenna in your computer and you are sure that is coming from the space because it's in your computer?
Well, what do you mean?
I'm telling you, you are sitting in front of computer. Some data is coming on your computer. You're saying this is coming from satellite from the space. How you can verify that? You said I have antenna. Yeah.
Hmm.
How you can verify it if surface is curving or not curving?
Because you measure
No,
the distance.
a part of satellites. Because we didn't have
Well,
satellites. We didn't have satellites 100 years ago, and we have these dimensions like a for a five even more 100 years. How
He
we
doesn't
got?
want to talk about that. He
I don't.
he doesn't want to talk about that. He said that already, like mad
Yeah,
times.
he doesn't want to
We
talk
can't
about the shape.
we can't force him. We can't force
Yeah,
him to talk about what he
I know,
doesn't want to talk
I
about.
know, but
Like so, a strength is to when to disengage unless you're going to engage the point that a person is trying to make. That's a strength, not a weakness.
yeah, it's all right to speak about satellites and speed, especially if you don't know anything about that and to
No,
speak
no,
about
no.
that.
My point is not. My point is not that it's all right to speak about satellites. My point is it's not all right when someone expressly doesn't want to speak about anything but satellites. The only thing you can do is engage the point or not engage, but it's not all right to tell them to talk about something else when they've clearly said they don't want to.
Okay, so
You
the
know what I mean?
satellites. So the satellites. There. That being said, I heard that. So the satellites. Okay, so how do you double check the satellite measurements?
well,
You
you
know,
can
there's
have
nothing to
multiple
double
sets of
check. There's nothing
you,
wrong with the calculations. The calculations are whatever, and they're going to make whatever assumptions that they make. That's not the point. The
Not
point is that you're making a measurement first.
right. Exactly.
Of course,
Eh, eh,
because you need to send that satellites in the orbit. You need to have all measurements before all dimensions because you're sending some things in the space. You need to know how big Earth it is. The fuck it will crash or something will happen.
I know. So what I'm saying is, so let's say, for the benefit of argument, that you have a good reason. Okay, whatever the reason is, to believe that those satellites are doing that thing. Okay, so what I'm asking is, how do you physically verify that? Double check it. How do you double check it? I think that's a good question.
double check that the measurement from you and the satellite is the
Yeah,
same.
how do you double check that physically to make sure what you're saying is correct? That being your conclusion that the surface of Earth is curving. So how do you double check it with reality?
You can have multiple sets of equipment. You can use. There's also you can have the satellite. If both the receiver and the sender of this are on the same clock, you can have the satellite send a signal, and if those two match up, and this can be done visually.
Okay, good. So that's exactly what I wanted to hear. Say now, how do you double check that with some other technology besides the one you're actually presupposing with? So you're saying the satellites are there. You're not using satellites as a proof of satellites. Well, I'm asking, how do you double check it against something else in reality to make sure that the conclusion is correct, being that the Earth's surface is supposed to be curving at a specific rate? Logically connect those two, please.
To be fair, is that even his conclusion? Because all I've really heard is that he can triangulate the position of a satellite.
No, with that triangulation,
And that was
with
that
that
was a
distance
big long,
measured, you
that
can
was
measure.
hold on, that was a big long fucking cricket moment. Did everybody catch
I
that?
was thinking.
No,
I
no.
was thinking.
Okay.
I was
Well,
thinking about the question, and then
that's a
he
straw
talked, so
man,
I
isn't it?
replied to him.
That's a straw man, isn't it? Who's what? Wait a minute. Maybe I missed something, but there's two different conversations going on. With celestial navigation, you most definitely use, you know, a part or a portion of the right angle triangle. You use the right angle part of it, but that's not the same as what we do with satellites. Though you still need elevation angle. So what are we talking about here? What are you trying to say? We're saying exactly. Do you deny anything that I've said up to this point?
One moment.
Yeah, because I have a citation for the first claim, and I also had a citation for the second claim.
Sorry, could you say that again?
Yeah, I said, do you disagree with anything I just said? Because I had a citation for the first claim and the second claim.
No, but before that,
That's all I said.
what are you referring to?
Well, you said something about us saying something about triangulation. Well,
Hmm.
who said what exactly? Because we're having two different conversations, so I'm trying to figure out what you think we're saying. Exactly. Yeah, same thing I asked you before you said hold on. Nothing's changed. Well,
I'm sorry.
take your time. I know this is new. Maybe. What you thinking about, hun?
I'm looking
Like,
at the
what's the key?
explanation that Kiwi Buzz sent about the celestial navigation.
Okay. Is this going to help you answer what I asked you?
I'm
Look at
still
the.
having trouble with what you mean by
What are you saying? We're saying. That's a very simple question.
the thing. I think what I'm understanding. I
You
know
mentioned
I've bring this up before with but
Yeah,
you
no,
said
but
this not was
what are we saying? That's the thing.
yeah.
What are we
Please,
saying?
one moment. I will. I brought this up before about this, but you said this is not what you mean. Is that you're using the angle, the like you had a specific word,
Elevation
elevation.
angle.
Yeah,
Mhm.
elevation angle.
Mhm.
And you use that to if we by using that you must know the angle at which the object is from you.
Okay. Okay.
Is that am
I
I
mean I don't know how the video and the citation the math, the equations that he does, all of that is in the screenshot, right? So you asked for the whole video, and I posted the whole video. So I mean, how much more clear can I be?
the whole video? Where is that? Did you post the whole video into the live stream texture?
Yeah, I did. Because the point is, you seem to have a problem with me saying no. You didn't, because you agreed. You said okay. The calculations come after the measurement. And I'm like, okay then. So the prerequisite would be a horizontal plane. And so I then asked, what's the problem?
What you were saying, but doesn't the using the
Does using the speed of light change it from the horizontal plane they started with? No. That why would it? Why would that happen?
we find
I'm just trying to get you to make your conclusion logically. That's all. You came in here with knowledge. This is the subject you wanted to talk about, so we're talking about it. I don't get the long pauses.
well, I'm not super familiar with the angle of I get the idea is that you're either using
It's not an idea. It's reality. What do you mean idea?
Well, it's semantics, but you're using.
Well, is an idea the same thing as something happening? Well,
it can be if
in reality. I'm sorry. Like if I'm looking at I'm sorry. If I'm doing something, is that an idea?
You can have an idea of a phenomenon.
No, I'm sorry. If I'm doing something, is that an idea?
It can be. No. This is a silly argument. This is a silly argument.
It's not a silly argument. I don't want to have to mute you, bro. Because I don't want to have to mute you, bro. It's not semantics is just understanding each other using defined terms. The problem is.
I apologize. I apologize. I won't use that word.
Don't apologize. There's nothing wrong with using the word. It's just you want to use it however you want. And the thing is, words have definitions. So that's the thing. Now, the entire point being that you can't just use definitions however you want to, bro.
Okay. We'll get back on track to the main issue.
Yeah, so what issue?
The angle of elevation.
There's a horizontal plane. What's the issue? That's where you start before you make any calculations. Yeah. What's the issue?
So you're saying we need the horizontal plane and the angle at which it's being measured
to
make a calculation.
Problem? What's the problem?
But you do not need the distance of the horizontal plane.
No, I didn't say that. But what's the problem?
No, I'm saying that you don't need the distance of the horizontal plane.
What's that guy saying with you?
I scrolled up, but I don't know.
Well, you're going to have to find it, and you're going to have to come back later, because I know you don't know now. You're just saying stuff. And I've been as reasonable as I possibly could. I'm not trying to embarrass you. You came in here saying, well, this is what I'm prepared to talk about. I'm like, okay, let's talk about it. And now here we are. You don't need to force it, because I'm not trying to embarrass anybody. You use a couple of fallacies, right? We can't deny that now. That's on the live stream. I pushed you and questioned you, asked you whether or not I was being unfair or unreasonable in any of my rebuttals to you. You said they were you didn't really you didn't have any argument against my argumentation at all. When I asked to define terms, we defined them. What's the problem?
But in
you
the video,
saying there's a problem, and I'm like, I don't understand.
In the video that you have sent me, I'm trying to see where he mentions the horizontal plane.
Well, if you look at the video that I posted, that was the citation of the video. right? You'd know exactly where it is. Like, I did that 30 minutes ago.
A lot of people are posting images
What that got to do with what I showed you 30 minutes ago?
because it makes it difficult to find what you have posted.
No, it's not about finding it. It's, I mean, Jesus Christ. Did you
What do you
see it or
mean?
not?
I found the video. I have not found the citation.
Did you see it when I asked you to see it when we were talking about it? Because you said you saw it at that point or not?
I thought you were. If I did, I must have thought you were referring to the 15-second part.
What do you mean 15-second part of what?
There's a short section that you sent me previously.
Okay.
But in the video, okay. Where is the? Is it just that one video that you've sent me? Is there an additional citation?
All right, 1 second. $23 minutes.
23 minutes.
Do you think that his
So could
story
I
about the horizontal plane is going to change? You think that, like,
could I
what?
just be given a moment so I can see what you're referring to?
Yeah, I mean, well, there's a video of exactly what I'm referring to. That's why it's called a citation. So there's the bit that I'm referring to.
Yeah.
So
I'm just
what's the problem?
watching through the section that you've referred to, which is 23 minutes.
Yeah, that's the citation that I've already posted not 30 minutes ago, 40, over an hour and 25 minutes ago. That's the
Okay,
citation I'm talking
I'm watching it now. Give me one moment.
about. Okay.
He doesn't mention anything about the using the Pythagoras idea.
I didn't say he did.
So he doesn't need a you don't need
No,
a
right
flat
there.
plane
He
to
said
you don't need a plane to
right
measure on
there.
the
No, you need an elevation angle measurement. So the degrees are dependent on starting with the horizontal plane and seeing the. He's talking about it right there. In order to get the position information, the distances and yada yada that you're talking about. And then he goes right there. He said the Earth is flat, but well, we know it's not. And then he says it comes over the horizon. So I'm very much in line with what we're talking about, and my point stands. Like, you're trying to get away from the fact that they're taking an elevation angle measurement. I don't get that. You see it right there. If you Google elevation angle, it's exactly what it would look
yeah,
like,
but they
just
use
like the one in the citation.
they use
So that's why I asked you, what's the problem? If what I'm saying is correct, what's the problem then?
that uses the distance gets the angle from a right angle triangle to find the position to where to point the receiving satellite, but you don't need that if you have a triangulated system, which he's not talking about.
Excuse me, but I
If
asked
you
you
have
to provide a citation for something that supports that you don't begin with an elevation. You need to be on the ground to receive anything. So I'm not understanding what the problem is. Like, he talks about how you have to point the whatever that little diagram
yes,
is
because
there.
he's talking about one satellite.
Yeah, it doesn't matter.
It does matter because if you have three, you
No,
don't need to take into
what
you
I'm
don't need
saying
to
is,
take into
if you have
account.
three, you just have three angles, right?
No, you
Are you saying that there's just no angles at all? What are you talking about?
if you have three satellites, the
So
angle
you
in
have
which they are
three
pointing
satellites
does
with
not.
no angles? Yes or no?
Yes, you don't need angles.
How is that? What do you mean? How is that possible? Give me a citation for that.
I don't have a citation on hand. I could
No,
explain
you
to
gotta
you
find
the.
it. You gotta find it, though. I don't need an explanation. I need a citation that supports what you're trying to explain. Because I already know that it's bullshit. So if it's not, just go ahead and cite something. Because I don't really, I don't like the BS. I just like to talk about the facts.
I don't understand the disrespect in the voice text.
Yeah, but you're supposed to be getting a citation, not looking in the voice text unless your citation is in there.
I have two screens, so I'm currently
No, but if you're
scrolling.
looking at the screen scrolling on the voice text, that means you're not looking for your citation. That's the
I am
problem.
currently looking for citations right now.
You can't do both.
Well, maybe you can't, but I can.
Well, all right. We don't want to hear you crying on the live stream while you're looking. So go on ahead and I'll put you on mute. When you come back with the citation that supports what you're saying, and then support of that,
Right,
then we're good.
yeah, so if you guys want, I can help research something.
Yeah.
So,
So
what is
if he could do that, two things at once, why can't he like tell us how to double check his freaking satellite supposed measurements? He doesn't know anything about with a curved triangle. What the? Once again,
Well, he dipped.
Wait, I can look it up. What is he saying about satellites and three angles? And
Yeah, that's the question.
No, what is he talking about? What's his problem? What's his problem? You know, that's literally it. Because I gave the information I gave. I said, is any of this incorrect? No. Well, do you need a measurement before you need a calculation? Yes. Okay, so what's the problem? Any more questions?
is this about spherical geometry and triangles?
No.
Oh, okay.
It's not. Well, what's
I'm
that?
not even.
What's a
Yeah, go
spherical
ahead.
triangle?
yeah.
Because that's a made-up concept. You can't use it for anything useful other than math and made-up things.
So he was claiming to know things about software. He didn't know anything about what an elevation angle is. So there we go. There's a big jump right there. So he doesn't know like the difference between theoretically, conceptually looking at software, whatever it says in the software, it doesn't fucking matter. It doesn't relate to anything in reality. When you go outside and look, the horizon, yeah, it's set to zero. He didn't know anything about elevation angles. It's suspect.
Well, you think just because somebody puts spherical in front of the word triangle that all of a sudden that makes it all good?
Hell no.
I can just say I'm white black. You know what I mean? What does that mean? I'm short tall.
I'm black white. Let's switch it up.
I'm slim thick.
Hey,
What?
hey, I don't have any money, but I have spherical money.
If Orsen's gone, we do have another globe earth in the room. Goes by the name of Pinky something or other. Hey, Pinky, how are you?
Spartans! What is your profession?
See, old friend, I brought more soldiers than you did.